and the instructor appreciates a material called the damped outrigger concept for tall buildings by these folks from Arab, London, United Kingdom that really provide a inspiration of making this video lectures. Thank you very much. And I want to use one of their figures tables for measure intrinsic damping of pole build. And if you take a look at this one here, this paper tries plot the relationship between heights and the damping ratio they measure. Very good job here. And if you go high-rise building around 300 meters here, 300 meters is approximately 100 floors of building. You count for 3 meters per floor. Okay. And your damping, if you go here, the damping is less than 1% here. As I said, the damping is very low for high-rise buildings above 100 stories here. But if you have a low-rise building, like 50 meters, it's just about 20 story. It's not low-rise, but still high-rise buildings. But if you're talking about 20-story buildings here, the dampings are varying from 6 to 7% to 1% or less. Right? So you have a pretty good damping for building range around 20 stories. If you go and see even lower building, your damping is pretty decent, like 6%, 7%. But your damping decreases rapidly here as your building goes up. So a 200-meter tall building, you have around 2% and less than 1% around this ranges of damping ratio. And if you go really high there, your damping significantly reduces less than 1%. So that is very important. So we need to put some artificial dampers because this damping ratio will not stop the building vibration or oscillation very efficiently. So this is not very good use and use these of dampings to design tall buildings, as you see, especially buildings in this area, in these regions. So that we need to use some artificial damping ratios, as you see over there, and you put the dampings here at all legal level, as we see something similar to this before, so they can provide a artificial damping to this building, so we can stop this building's isolations and reduce the deformation of the building very quickly and efficiently. Here, okay, if you see right there, we have a columns here, and we have here pressure vessel with the valve, and this is connection block, and this is outrigger part, right? So that when outrigger activated, this pressure is going to provide a damping to this building as artificial damping rates. Okay, and we'll see the schematic typical layout at all legal levels, and this figure is very good for us to understand how outrigger must be laid out with the damper and how the outrigger connects with the perimeter columns right there. So we have a two-sided in two direction for outrigger structures, and we have a core walls. Of course, the outriggers are nothing more than connecting core walls and exterior columns here and here in this directions, and we have another outrigger for the other directions similarly, and we have a pressure type of damping device is there. So it can provide a artificial damping to the building. This is a door, as I said. We have to go down and check the maintenance of the outrigger floors. And this is outrigger walls. In case we have a outrigger trusses, we don't need wall door, something like this, right? And we have a connections over there. And this is core, central core walls. And this is a perimeter columns, beam and floor slab omitted for clarity. So we don't provide a beam and slabs here to make these details look more clear. This is very nice typical layout. You can design something similar to this in your projects, and this should be the same for all outrigger. Mostly you see when you go to firm for your future career.